Hi everyone. So today we'll be looking at some more Earth Engine applications, specifically looking at chapter A2.1 on groundwater monitoring with Grace. So for this video specifically, you're going to look more at the chapter overview and the theory, and then we'll leave the practice to some of the other videos. To access the chapter in the book, there's the link below, or there's the official book link where you can find all of the different chapters for anything you would like. So giving a chapter overview, the goal of this chapter is to learn how to use observations from GRACE, the Gravity, Recovery, and Climate Experiments, to analyze changes in groundwater storage for a large river basin, specifically looking at California's Central Valley. And so what you can expect to learn out of this video and these videos is how to plot changes in total water storage using GRACE, mapping trends in water storage, resolving changes in groundwater storage for a river basin, importing image collections and creating image collections, and creating charts. This is assuming that you know different things from the different chapters that you've seen before this. So using expressions to perform calculations on image bands, writing a function and mapping it, fitting linear and nonlinear functions with regressions, using the spatial join, filtering a feature collection, and all of those have their assigned chapters. So I really invite you to go back and look at those if you feel like you need some form of refresher, because in the code that we're going to see, I'm not going to dive super deep into all the details. It's really just to show you how to use these observations from Grace and how to do stuff with it in Earth Engine. So let's dive into the theory a little bit because I keep mentioning Grace and I want to explain to you a bit what that is. So Grace twin satellites. Since 2002, Grace and the follow-on mission Grace FO are a satellite tandem that provide a new vantage to track changes in water resources. And Grace has a unique ability to track changes in total water storage anomalies, which is the TWSA, according to the following equation and gravity. Grace uses a gravity measurement technique that works by measuring changes in the push and pull between the twin spacecraft as they orbit. And just quoting NASA, Grace measures changes in the local pull of gravity as water shifts around Earth because of seasons, weather, climate processes, providing, among other things, insights into where global groundwater resources are shrinking or growing. And so there's other things that it does, but I do invite you to go research it, learn a bit more about it, and it's really worth checking out. And there's a link below to learn more about it. So this equation specifically, I invite you to also go visit the slide because I'm not going to dive deep into it, but each has its own term, and we're going to look in the code at the soil moisture, the snow water, so we're all going to look at that. But this equation has the canopy water storage, the surface water anomaly, the soil moisture, snow water equivalent anomaly, and groundwater storage anomaly. And you have this diagram here just to give a bit of context on groundwater, where it goes, what it is. And lastly, before we get into the next videos, which are going to really look into the script, you can access the book scripts in Earth Engine through this link. And if nothing's showing up, you can use the refresh button. And basically is going to take you into Earth Engine here. You have what you need in here for A2, and we're looking at A2.1. And we're going to look at these checkpoints, copy paste into a new script, and run everything by part just so we can understand what happens. So I'll see you in the next videos.